Hello dear students, this is Professor Dharmendra, Faculty Department of CSE, Sagar Institute of Science, Technology and Research, Bhopal. Today we will discuss about software configuration management. It is also a very important part of software engineering. Before start our presentation, we need to understand a presentation policy. As we are working on Smart City project for references and to visualize the concept, in this presentation you will see some references starting with SMRT_city. So you are instructed to relate the concept to the project for better understanding. Thank you. Let's start with the software configuration management plan. So why SCM is needed and why we create a plan, we need to understand that. The SCMP or software configuration management planning process planning begins at the early phase of a project. Actually, planning is very important. You all know that. So all the configurational things, managerial things of the project, we decide in a early phase. The outcome of the planning phase is the SCM plan, which might be stretched or revised during the project. As the project further get developed, if it is needed some revisions, so we take upon the revisions also and take a iterative approach to make it better. The SCMP can follow a public standard like the IEEE 828 or organization specific standard. So you know that IEEE 828 is a public standard which means that it has defined some guidelines for creating software configuration management planning. So either we can opt that standard guideline or we can opt organization specific standards for designing our software configuration management plan. It defines the types of document to be management and a document naming. Types of document means whatever the policy we are following in the naming conventions, we take a standard mechanism like IEEE 828 or some organizational guidelines. So in the Smart City project, as we discussed, SMRT_city, the SC_test_v1 could be a mechanism to define. SC means Smart City, _test means we are testing something, and the version, on what version we are testing. So it could be a test program also. So how we name it, we need to understand here, because a software product can have thousands of files. So it is very hectic to manage all the files if it is not named in a proper manner. So we need to modularize things so we can have the file name and we understand what it will do as understanding the file name. SCMP defines the person who will be responsible for the entire SCM process and creation of baselines. So what we do here, we give the responsibility to certain person who will handle it, and we actually make a base structure here from which we can launch our software configuration management. Fixed policies for version management and change control. Very important things are there. If we don't have a fixed policy, it means that if we not decided something as a prerequisite, maybe some surprises could happen at the time when we have same code for multiple definitions, or when we need to connect to different things, different server locations. So the versioning should be done. We will understand it more better further. define tools which can be used during the SCM process. Whatever the tools we will use, we will make sure that they all are in our development space where they can be incorporated. Configuration management database for recording configuration information. So whatever the configurations we have decided, they has to be recorded in some place, and that database has to be configured properly. So why do we need software configuration management? Why SCM is needed? So we need to understand it. First, to handle concurrency. Concurrency is a very important part. You all know that if system is not going live, if the project is not live, then we can do any experiment with that. But if it goes live and at the live situations we change something, then a ripple effect can be generated which will be not handleable sometimes, so system could crash. So to avoid those situations, we need to perform concurrency management very well when two or more tasks are happening at the same time. It is known as concurrent operation. Concurrency in context to SCM means that the same file being edited by multiple persons at the same time. If concurrency is not managed correctly with SCM tools, then it may create many pressing issues. So we got to know that it is very important, because if we are working on same resource, then if multiple users are working on that, then it could be a dirty read problem, or some other problems could happen where file cannot be accessed because first version can apply a lock on that. So many cases can happen in concurrency management that has to be addressed. The second one is version control. As we have already discussed, version is very important. If we create a code for something like if we have two IP addresses, the first IP address is for database 1 and second IP address for database 2, and we need to make a version of same program in two variants. So version number should be mentioned properly. So SCM uses archiving methods or saves every change made to file with the help of archiving or save feature. So it is possible to roll back to the previous version in case of issues. So if we have some updation in our file, then if updated version is not working perfect, then we have to roll back it. So it can work at least with the previous situations or previous software version. The third is synchronization. Users can check out more than one files or an entire copy of this repository. The user then works on the needed file and checks in the changes back to the repository. They can synchronize their local copy to stay updated with the changes made by other team members. So you heard about Dropbox, where we synchronize things in a common manner. So this could be an example for to understand that this concept. Now, what are the key players in SCM? So you can see 5 arrow lines are there, 5 arrows are there. So obviously it is 5 player space, where the first player we can say auditor. So actually the role of auditor comes at the last, because it audit the things done by these players. So who are they? Let's understand that. The project manager, which manages all project happenings or process. The second one is configuration manager, which manages the configuring things of the project. And developer, which codes, the person who codes, actually coding things can be done by developer. And the user who uses that particular developed software. So SCM operational scenario covers these 5 players. So let's understand the workings of each player. Configuration manager, what it do? Configuration manager is the head who is responsible for identifying configuration items. Configuration manager ensures team follows the SCM process. He or she needs to approve or reject change request. So you can say that in a particular module, if configuration manager decides that the requested change are or will not perform well, then on the experience he or she can reject or accept the proposals. So you can see the overall management done by configuration manager for a module. Developer, the developer needs to change the code as per standard development activities or change requests. He is responsible for maintaining configuration of code. The developer should check the changes and resolve conflicts. So you can see many modules can have a single access to a same file, or they coordinate together, they synchronize things. So in a joint activity, when something like conflict happens, then there is a responsibility of developer to resolve those conflict and check the changes. The auditor is responsible for SCM audits and reviews. So एक तरह से बोल सकते हैं ये critics की तरह काम करते हैं. Need to ensure the consistency and completeness of release. So when before release, the auditor plays a very important role for the final check of the consistency and completeness. The fourth one is project manager. They ensure that the product is developed within a certain time frame, monitors the progress of development and recognizes issues in the SCM process, generate reports about the status of the software system, make sure that processes and policies are followed by creating, changing and testing. So you can say that the overall software responsibility on up to the project manager level, who ensures the overall functioning, creation, testing and updations. So all the things managed by project manager in that level. The last one is user, and user should understand the key SCM terms to ensure he has the latest version of the software. So these are the 5 levels or the 5 players, we can say that, who plays their roles. And finally we got a SCM based project or SCM guideline based project. So let's understand SCM, software configuration management. It uses the tools which keep that the necessary change has been implemented adequately to appropriate component. The SCM process defines a number of tasks. So we can say that if we have a checklist of some things, then it identifies that the desired task is completed or not. So there are some phases of SCM. The first one is identification of object in the software configuration. The baseline has to be created here. The second one is version control, where we defines the version. The versioning is doing in a proper way or not. The third is change control. All the changes are working fine, or they create some havoc situation, or some code faults are coming. So change control is very important. Also configuration audit, which take a checklist that all the configurations synchronized together in an appropriate manner. And the last one is a status reporting. So these are the 5 phases. So SCM process in a single depiction, we can see a diagram here where identification is the first one, as we know, the version control, change control, configuration audit, reporting, and the cycle goes on likewise. So further, the first phase is identification, where to control and manage software configuration items, each should be separately named and then organized using an object-oriented approach. Two types of objects can be identified. The first one is basic objects and second one is aggregate object. So basic object, you can see the baselines, and aggregate means add-ons. So a basic object is a unit of information that has been created by a software engineer during analysis, design, code and test. So SDLC life cycle की बात हो रही है यहाँ पर. For example, a basic object might be a section of requirements specification, part of design model, or a source code of component. So let's have an example of a smart city where we define dustbin location, that could be a basic object, and UML of waste management, that could also be a basic object, or some source code can also be a basic object. So an aggregate object is a collection of basic objects. Each object has a set of distinct features that identify it uniquely. Maybe it could be a name, a description, a list of resources. So in a smart city, we can have the coordinate list of GPS coordinate list of all dustbins. So we can name it dust underscore bin underscore GPS underscore coordinates, which defines a list of all the dustbin has to be plotted in the city at various locations. So further, in between, we need to understand how it actually works. How module get interconnected together, how a module interconnection language works. So the relationship between configuration objects can be described with a module interconnection language. What we are doing here, we are identifying interrelationship between configuration object. So how objects are coordinating together, this has to be defined. So let's understand with this with our diagram. So you are seeing here there is a MIL source code is here. This is the script of module interconnection language, and this is a graphical presentation of this particular code. So as you can see, if you see a diagram, a graphical representation of this code, you can understand what is going inside and what is going outside. So there is a module ABC. You can see module ABC provides ABC. This is going as a providing things in this direction, means data is going out, and requires XY means it get input of XY. Consists of function XA and module YBC. So XA and YBC, these are the functions, and there is a module YBC, function XA. Function XA must provide A, so there is a compulsory requirement of giving A. Requires X, has access to module Z. So again, arrow is pointing to Z, which shows that XA has the access rights for module Z, and real X and integer A. So you can see here all the things can be depicted with a diagram. So this is a good approach where you understand things with just a snapshot view or a graphical representation. Version control. So configuration management allows a user to specify the alternative configuration of the software system through the selection of appropriate versions. This is supported by associating attributes with each software version and then allowing a configuration to be specified and constructed by describing the set of desired attributes. Like we can have an example of versioning. Instead of naming a file like login.php, it should be named login underscore v for version 1.2.php, where version 1.2 stands for the version number of the file. So we can have a reference also. स्मार्ट सिटी प्रोजेक्ट में हम टेस्ट लोकल फोल्डर के अंदर login underscore version 1.2.php फाइल को डिफाइन कर सकते हैं, which connects in a local mechanism. So we can have another file like login underscore version 1.1 which can connect to the server. So both the variants are possible here. Instead of naming folder code, it should be named code underscore bk underscore d, where d represent code should be backed up daily. So there are some provisions we can create, like in a smart city we can create backup underscore smart city folder, where date underscore bk underscore d file will get run, be run on the date change, on the occurrence of new date. ठीक है, so ये दो एग्जाम्पल हैं जो यहाँ पर वर्जन कंट्रोल को समझा रहे हैं. The third one is change control. Now we are working on change. What changes should be applied in a particular software? So change control is a procedural method which ensures quality and consistency when changes are made in the configuration object. In this step, the change request is submitted to software configuration manager. So a software configuration manager will decide that the change request should be accepted or not. We already understood it. So activities during this process are control ad hoc change to build a stable software development environment. Changes are committed to the repository. So whenever a change take place, all the related information of that particular change has to be recorded, because at some time if we find something faulty, then we need to identify that which change made it possible, or because of that the fault is coming. So we need to identify, we need to take a proper log report of that particular change. The request will be checked based on the technical merit, possible if side effects, and overall impact on other configuration objects. So we can we should identify that what kind of risk this can there is a possibility of risk, and what level of impact this particular change will take place. So after that we define the final approval. It manages changes and making configuration items available during the software lifecycle. So these are the 3 steps. Change control further continued. The result of the evaluations are presented as a change report, which is used by a change control authority, CCA, a person or a group who makes a final decision on the status and priority of the change. The check-in and check-out process implements 2 necessary elements of change control. The first one is access control, and the second one is synchronization control. So who is accessing it and how it is getting synchronized, and these has to be identified. Okay, so what is access control? Governs which software engineers have the authority to access and modify a particular configuration object. Synchronization control helps to ensure that parallel changes performed by 2 different people don't override one another. So we take care of that. The synchronization should be there. So let's understand software configuration audit. This is the fourth phase. Software configuration audit. Verify that all the software product satisfies the baseline needs. It ensures that what is built is what is delivered, obviously. So activities under this phase. Configuration auditing is conducted by auditors by checking that defined processes are being followed and ensuring that the SCM goals are satisfied. So I already told you that audit is has some checklist, that this has to be a target, and this is the accomplishments, and the accomplishment should meet the targets properly. So to verify compliance with configuration control standards, auditing and reporting the changes made. SCM audits also ensure that traceability is maintained during the process. Ensures that changes made to a baseline comply with the configuration status reports. So what is decided should be delivered. Validation of completeness and consistency. Further, now status reporting. This is the last phase. Configuration status reporting, sometimes also called status accounting, which provides accurate status and current configuration data to developers, testers, end users, customers and stockholders through admin guides, user guides, FAQs, release notes, installation guide, configuration guide, etc. So you can say that this is the overall reporting system which identifies all the things, how things are going on, what are the participating elements, how system will behave, and what will be the result. So overall things will be given here in the status reporting. Further, in the status reporting, configuration status accounting tracks each release during the SCM process. This stage involves tracking what each version has and the changes that lead to this version. So deployment of every version, after the deployment of every version, there are some manual things deployed to introduce the things that what a new version is having and what are the facilities it is providing. Activities during this process keeps a record of all the changes made to the previous baseline to reach a new baseline, identify all items to define the software configuration, monitor status of change request, complete listing of all changes since the last baseline, allows tracking of progress to next baseline, allows to check previous release versions to be extracted for testing. So overall we can say that where we are standing, what were the things, and what next can be implemented. So all present, the past, near past, or you can say that the last thing that we do, and the next thing we will planning to do, and we will plan to do what is going on, and these three things has to be defined in the status reporting. So the first point is very important here, keeps a record of all the changes made to the previous baseline to reach a new baseline. So thank you for joining.